Well, here we are on Generation 364, looking at the best of Generation 364 of uh, of a creature that I made in the evolution program, in Keiwan's evolution program, um, for climbing, specifically to handle the task of climbing. Now, I designed this creature to be able to climb. Uh, so you might wonder then, what does evolution have to do with it? Well, first off, evolution is the accumulation of change. I didn't design this creature in one step. I actually tried quite a few different things, and when it came to this particular creature, I had an idea in mind of what I wanted it to look like, how I thought it would work, but I had to make quite a few changes before I actually managed to get one this successful. I really think the program should start out with the climbing task not being quite so daunting. That's a very steep incline, and the virtual muscles in this system don't do a real good job of lifting things up um, that steep of an incline. But as you can see, this one's handling it quite well. In the measurements in the program used in the program, it's going at an average speed of 1.49 meters per second here, and now generation 366, achieving in a 60-second run per generation. In this case, a vertical distance of 58.7 meters. Now, it starts out by default with 10 seconds per generation, and I had left it that way up to, I think, about nearly generation 200, and then I increased the time to 60 seconds per because I wanted to get a better um, fitness measurement uh, to compare which ones were actually doing better than others, because a lot of them were doing a reasonable job of climbing for short periods of time and then basically getting stuck and just stopping. And as you can see, this is still doing that somewhat. It's not real precise at it. It hasn't learned to place its feet neatly on the stairs or anything like that, or however you want to word it. It's just basically it's using one foot, if you can call these feet, um, to place on a stair when it manages to, and the other one it generally sends back behind that one, downward of it, and then throws it upward to get some momentum, to lift the whole thing up and carry it up to a higher stair. And if you look up in the upper right hand corner, you can see a bunch of them competing. And if I switch over to that, that's the current generation actually being tested, and I'll switch that to the main screen, and there you can see a close up of, oh, there it switched generations here, generation 370 now. Um, it basically looks like a big blob of red dots with black stuff behind it. But as they climb and compete, they will spread out a little, and you can see the muscles, red and blue. The muscles in this program have an expanding mode and a contracting mode. Contracting is in red, expanding is in blue. If they're relaxing, I don't know whether that's red or blue, or even if they're capable of relaxing. Maybe they're always either expanding or contracting to some degree. And that I also don't know. Do they have the ability to contract or expand small amounts and large amounts? Or do they just switch back and forth them rapidly to sort of simulate that? These are details about how the program works internally that I don't happen to know. So, any rate, I suppose I could have turned on autosave and let it save this. I'm just going to click save once here here at generation 371 in case I want to reload that. And I'm going to go ahead and go back to the design board. And here's that creature. I want to give it a name, and I want to save it in case I want to reload it. I'm not sure if I've saved this exactly as it is. I think I did. I think that's actually the one that I named C3. Oh, which is not showing up in here at all. And so maybe it will and maybe it won't. Yeah, I'm not sure what happened to that. So I'll go ahead and just name it something. Now, there's a bug in here with, I don't know, this doesn't seem to happen with other people's keyboards. I haven't seen it happen to anybody else. But with my keyboard, when I hit a letter, it shows up twice. So, let's see. I'm just going to name this Woo, just for the heck of it. And I'm going to just take my mouse here and select this first W and hit a backspace, which comes out as 2 backspaces, but it gets the job done. So the creature is saved, and I may or may not be able to find it in the menu later because basically I let the thing run until it crashed, which is how I got up to such a high generation level. There it is, Woo, in the list. Because running a minute per generation takes a long time, and it didn't crash with an error. It just sort of went away, and then I had to reload it, which might be why I lost the saved creatures. Now, what I'm going to do is I'm going to, well, it's already switched. I was going to say I was going to switch it over to the running task. Climbing is what I had it on, but the way I did that was I went load simulation, and when you do load simulation, it gives you a list of simulations. You can drop the list down. You can see here 371 is the one that I just did. I'm just going to cancel that, but that's how I got in there, and it was already in climbing mode then. But right now I'm going to go ahead in running mode and just click evolve, just to show you. There's the flat ground that most things are tested on. Generally, people start out in running mode, and climbing mode, you saw they climbed pretty well. I'm going to go ahead back into climbing mode and just show you. If I restart evolving, what's evolving is the neural network that tells it how to climb. So this is the exact same body, and you can see that looks a lot different than the way generation 371 started out. We got a lot of stuff just falling over. Now, the best of that first generation is doing this. A little clumsy, but not as bad as the average. Actually, extremely clumsy. And you notice it doesn't actually know how to go uphill, but at least it's figured out how to stop itself from rolling downhill, which makes it the best of the early generations. Here we're up to generation 4. Again, sliding downhill a little bit, but not that terribly bad. And each generation, it breeds from a population. In this case, I'm going to go back here and you can see the settings. Up in the upper right hand corner, you can see the population is 10. So there are 10 individuals in that population. And now I'm going to go back to running, and let's just let it evolve for a little while as a runner. And you can see one of them broke there. I don't know if you noticed that. Once in a while, that sort of thing happens. One of them just flies apart. And yeah, and it's following the broken one, the flying apart one. But I'm going to switch this over to the best of, and you can see what that's doing. Oh, there. the best of flew apart. Now, there's a way to get around that. If you end up with one that flies apart and it thinks it's the best one, there's a thing here that says keep best creature for the next generation. Turn that off if you don't want it to end up with something that's flying apart, being copied from one generation to the next because an error in the physics engine um, tells it that that flying apart one is the best of the generation. Because otherwise it's kind of hard to get rid of it. Eventually, you might get a mutation in it um, that'll fix it. But yeah, not even sure exactly why that happens in there. Again, stuff that's internal to the program, and hopefully the developer will figure it out someday and fix those things. But it's still a neat program. I mean, no computer program of reasonable complexity is likely to be perfect. I mean, sure, you can write a hello world program that functions exactly as intended every time, provided the computer functions exactly as intended every time. Uh, but yeah, so okay, we're up to best of generation 11 here, and still flying apart. Showing a fitness of 29.93. I'm going to just go back and restart it because whatever it was that got into that thing, it doesn't seem to be going away. So click evolve. Again, hit the pause and tell it don't keep the best. So, in other words, what it means by keep the best creatures for the next generation, as I understand it, the way that they're reproduced, they're paired up randomly or somewhat randomly, with a slight preference toward picking parents that were more fit rather than less fit. But two of them, if that's selected, are reserved. The two that are rated as the most fit are reserved, and rather than being two of them being bred with each other and producing two offspring, instead they're basically cloned. I see something interesting going on in Generation One. Um, it almost looks like it's trying to walk on the large ends there, and there's another kind of walking being tried out. And this is how that works. Um, it starts out with a bunch of randomized, well, in the case of population 10 randomized neural networks that have no idea how to do the task it's being asked to do. And each generation runs for a certain amount of time, in this case 10 seconds, and is then measured for how well it did at the task, in this case moving toward the right, which is labeled as running. And there you can see it's moving toward the left, which is not real good at moving toward the right, and there it's going back toward the right again. So overall, it's going to have, depending again on how the program internally decides just how well it did, it's going to get a fitness rating, and then that fitness rating decides it helps the program to decide which ones uh, to prefer in breeding new offspring for the next generation. Similar to the way that nature sort of um, picks what gets to breed for a new offspring based on attractiveness and survival and things like that. And so yeah, if I leave this run for a while, I know because I've already tested it that this creature will actually be able to learn to run pretty well. But I don't want to make this video real long, so I'm going to go ahead and back out of here. As you can see, it is working out a strategy for running. This is not like any strategy I've seen it used before. So going back, and now there is a jumping exercise, and then there's an obstacle jump. I haven't seen anything get good at the obstacle jump, including this. So I'm going to just let this one evolve for a little while and just see what it does on the obstacle jump. I haven't done much testing on the obstacle jump, um, for the simple matter of fact that on this creature, I haven't done much testing of the obstacle jump because pretty much nothing does any good at the obstacle jump that I've seen. And they can hold part of themselves away from it, but they don't seem to get the idea they're supposed to jump over it. And that sort of makes sense if you consider the fact that the obstacle is rather large right from the start, and a small amount of movement isn't likely to get it out of the way. What's actually being measured, according to what I've read, as far as fitness goes, in the case of the obstacle jump, is how many nodes come into contact with the obstacle as it moves by, or how many joints, the red dots. And as you can see, they are sort of here up to generation 8 now. Uh, they do sort of seem to be getting a little bit of timing involved there, where they sort of sense the obstacle coming and try to move out of the way a little bit, but they're not doing a real good job of it. And here, if I look at the best of generation 9, you can see basically the two nodes on the lower left. It looks like it's making some attempt to get those two joints out of the way, and not doing a real good job of it. Now, if the obstacle were to start out smaller, the way it's doing it right now, it might actually be able to get those two out of the way of the obstacle entirely. I think the first one would still be getting, the one on the lower right would still be getting ran over. But at least that would sort of, encourage that a little bit more. As it is right now, I think it's sometimes getting one of those two out of the way, and that's enough to encourage that sort of movement slightly. By encourage, I mean that that increases its rated fitness just a bit. So future generations are more likely to inherit that way of thinking. That, in other words, attributes of the neural network that caused it to have that behavior. Now, as individuals, these things don't learn at all. So if I made, for example, one generation, say an hour long, 3,600 seconds, by the end of that hour, that one generation would be no better at what it's trying to do than it started. Now, I could be mistaken. A programmer can correct me on this if he sees this and wants to do so. But this is a sort of standard way of doing this kind of evolutionary development. It is possible to add some learning of the individual into the system, but that learning of the individual is generally not inherited. Now, that's not to say that it couldn't be inherited, but usually these things are set up to sort of mimic biological evolution, and that's the way it works in biological evolution. If you manage to get better at something, that doesn't mean your offspring are going to be better at it. Now, if it's learned tasks, you might be able to teach your offspring to be better at something that you learned to be better at. But, like, say, for example, if you work out and build your muscles up bigger, it doesn't mean that your offspring is going to be able to have bigger muscles because you worked out and had bigger muscles before having a kid. It just doesn't work that way. So, yeah, I think I'm going to call this good enough for now, and I'll just leave this run with its attempting to evolve the ability to avoid the obstacle. And I'm going to go ahead and switch back to this other screen so I can use the save button. And I'm going to save this at generation 29. And I'm going to click auto save. So it'll save again when generation 30 ends. And I'm going to stop recording here. And if this thing gets really good at avoiding the obstacle, maybe I'll make another short video showing that. Thanks.